Today in this video we will talk about Pharmit server. Pharmit server introduction. Pharmit server is a web-based server where users perform visual screening by pharmacophore and molecular shape, and furthermore it refines the result by energy minimization step. Pharmit enables the user that they can perform a screening by two ways, by creating a pharmacophore query and by on the base of molecular shape. And furthermore, the last step it provided after the results are shown is the energy minimization step. User can minimize their results. Pharmit provide a pre-built compound libraries for screening, and in addition it allows users to upload their own compound libraries for screening. Pharmit provide two ways by which user can screen the database by uploading their own compound libraries and by using a pre-built compound libraries that are already available in the Pharmit server. Pharmit enables users to search for a small molecule based on their structural and chemical similarity to other small molecules with the goal of identifying those that bind to a target molecule. When the screening starts, the small molecules are searched on the basis of their structural and chemical similarity with the other small molecules that are already available in the database, with the goal that they also bind to the target molecule and they restrict their biological activity. A pharmacophore is the symbol of steric and electronic features that is necessary to ensure the optimal supramolecular interaction with a specific biological target and to trigger or block its biological response. A pharmacophore query is basically a combination of steric and electronic features of a molecule. Steric features are the non-bonding interactions, and electronic features are the bonding interaction. And steric features influence the conformation and reactivity of the molecule, and the electronic feature influence the structure, reactivity, and properties of the molecule. Features spotted by a pharmacy include hydrogen bond donor, hydrogen bond acceptor, negative and positive charge, aromatic and hydrophobic features. The pharmacophore features, pharmacy provide a pharmacophore features for pharmacophore query that will be a hydrogen bond donor, acceptor. It may be a negative and positive charge, aromatic range, and hydrophobic feature. User can choose their own pharmacophore features for their screening process. The next is about shape queries constraints. Similarity of molecular shape is a common method of structure-based visual screening. Pharmit uses the volumetric aligned molecular shape method of shape search, which use inclusive and exclusive shape constant to identify matching molecular shapes. Similarity of molecular shape is basically another method where user can screen a database on the basis of structural based screening. Pharmit basically use a volumetric aligned molecular shape method for a shape search, which use inclusive and exclusive shapes. Inclusive and exclusive, there are further two ways where user can search a database on the basis of inclusive, that is about ligand, and exclusive, that is about receptor. Inclusive constraints are specified using the shape of the provided ligand. Inclusive constraints specify a minimum bond on the desired molecular shape. Inclusive is all about the ligand shape, and inclusive constant is specify a minimum bond on the desired molecule, and it allow the compounds to overlap the constant. It allows the matching compound allows to overlap these constraints. The next is about exclusive. Exclusive constants are specified using the shape of the provided receptor. Exclusive constants are used to limit the desired molecular shape. Matching compounds are prohibited from overlapping these constraints. Exclusive constraints are all about the provided receptor, and it limit the desired molecular shape, that it not allow the matching compound to overlap these constraints. It prohibited in the it prohibited the overlapping constraint. The next is shape constant is applied differently depending on whether it is used to search the database prior to pharmacophore filter or to filter result returned by the pharmacophore search. Shape constant is applied differently. It depends on the user requirement, whether the user want to apply it before the pharmacophore filter or after the pharmacophore filter. In this picture, there is a shown that a gray highlighted area is all about the receptor, that is inclusive region, and the yellow portion is all about the ligand, that is inclusive region. We can add them by inclusive or exclusive shape filter, and there we can also use to hide them, and we can also show them in wire form and in the solid form. Next is how to start a searching process. There are three ways to initiate a search with Pharmit: from a PDB accession code, from a receptor ligand files, including both a receptor and ligand as well as ligand by itself, or by using a pharmacophore generated from external source and upload to a Pharmit. Pharmit provides three ways where user can start their searching process. In the main page, there is an option available for a user that they can enter their PDB session code and they start their searching process. And the next is there is an also another option available, that is enter Pharmit search, where user can enter and then they can upload their receptor or ligand file, and they can also further upload a single ligand, and they can also upload a receptor and ligand both files. And they can also upload the pharmacophore generated query from an external source like from MOE. The first is about from PDB. A structure can be obtained directly from the PDB by entering its 4-character PDB identifier in the first text box after start from PDB as shown in the figure below. To initiate the APPS searching using this method, the user may enter APPS in the box. This process is all about searching process, and user can add the session number of the PDB ID, and they can start their searching process. A list of possible small molecules will be generated automatically in the second box, from which the user may choose a ligand of interest. To proceed with the search, the user should next choose submit, and there is another option available for a user that they can choose a ligand of their interest by choosing them, and they can start their searching by submit the process. In this picture, there is a highlighted portion in the yellow box, start from PDB, the where user can enter their PDB accession code, and they can also choose their ligand of interest. And there is also another option available for a binding site water, where it's totally depend upon the user where they can add them or ignore them. So we are ignoring them in this process. The next is about from receptor ligand files. Alternately, the user may first use enter Pharmit search in order to upload structural files. After being redirected to search page, choose load features to upload a small molecule structures in STF, PDB, MOLT or XYZ format. A receptor file in any of the same format may be optionally be provided as well. And the next is about from receptor ligand file, and the main page shows a option that is enter Pharmit search. When the user click on it, the Pharmit will take into another page, that is where user can upload their structure file by loading the receptor, where can load their receptor in the XYZ format, in the STF, in the PDB, MOLTO or whatever the user want. Or in the load feature click, they can upload their ligand small molecule structure in the same format in the STF, PDB, MOLT or XYZ format. Our example use both ligand and receptor. To initiate the APPS searching using this method, the user should load the attached receptor and ligand files as the receptor and features respectively. These files were obtained directly from the APPS PDB entry and are provided as example of possible input formats. The user now we can start our process of searching. We can enter a APPS session code number in the, and we can also upload the receptor and ligand file for the searching process. And we are using a receptor and ligand file to upload and then start our searching. If a receptor is provided for the load receptor option, it should be one for which the binding pose of the provided ligand is known, or to which the ligand was previously docked. When the receptor is loaded, and then it must be previously docked with the ligand that we are loading in the load feature option. Pharmit will not dock the two compound, and since the receptor is used to identify which pharmacophore feature of the ligand are relevant to binding. Farmit will not provide a docking process, and they will not dock that the two compound and the receptor. When we load a receptor, the pharmacophore features, then the Farmit will identify those pharmacophore features of the ligand and protein that are involved in the binding process. If a ligand structure is provided without a receptor, the query will proceed normally, but the user will not able to energy minimize the result of the queries. Since the calculation depend on the presence of receptor, as the if we provide a ligand without a receptor, then the query will proceed normally as we provide a ligand receptor both in the previous. When the ligand is loaded without a receptor, then there is a last step that is about energy minimization. Then this step is not available because this step is available on the presence of a receptor. The next image is shown the example of uploading a ligand structure without a receptor. In this picture, there is shown a load receptor option and there is shown a load feature option. From a load receptor option, we can upload a receptor file, and in the load feature, we can upload our small molecules, and we can also upload our pharmacophore feature generated from an external source. Whenever we uploaded a load receptor and load feature option, we can only upload a ligand load from a load feature option. As a ligand is uploaded, Pharmit automatically enables its pharmacophore features that are involved in binding interactions. As in the left sidebar menu shows, the hydrogen bond donor, hydrogen bond acceptor, hydrophobic, and other hydrophobic regions. And the right sidebar menu is shown their pharmacophore results. Pharmacophore representation. A list of pharmacophore features is provided in the pharmacophore menu in the sidebar. As the previous picture shows that the pharmacophore features are shown in the left sidebar menu. Pharmacophore features can be toggled on or off, include them or remove them from the search. We can also it's depend on the user where the user want to include them or exclude them. Pressing the X to the right of the pharmacophore removes it from the menu entirely. By pressing the arrow to the left of the given pharmacophore, the user can vary the type, radius, and location of the pharmacophore. The pharmacophore Farmit enables the user that they can entirely remove a pharmacophore feature by pressing the X option available on the pharmacophore features sidebar menu, and they can also vary their type, radius, and location of the pharmacophore. It's totally depend upon the user, what's the user requirements. As this picture is shown, the pharmacophore features are shown in the left sidebar menu, the hydrogen bond donor and the hydrogen bond. There is another feature that is shown that about they can choose their radius. Only 1.5 angstrom is basically a good ideal radius, as like in this where we can also exclude the atoms in the hydrophobic feature. The next is about heat reduction and feasibility screening. Additional heat reduction and screening options are provided in the filter menu. The left sidebar menu provides a filter menu where heat reduction and screening options are available. The three options for heat reduction include restricting the maximum heat return from every configuration of every molecule and overall. The three options are available in the filter menu, where the one is that the returning of the restricting the maximum heat return for every configuration. The maximum heats per configuration constant is applied greedily, returning the first end result without prioritizing any other aspect of the results. The other two constants are applied after the results are sorted, giving priority to those higher rank, lower RMSD of the pharmacophore search, and the higher similarity score for shape search. The maximum hit per configuration constant is applied greedily without considering any other factor that involved in the ranking. and they can also the other two constants are applied after the result are sorted. It's all about the lower RMST means when the user perform visual screening on the base of Pharmacophore, they can rank their result on the base of lower RMST to higher RMST, and when the user perform on the base of molecular shape, they can filter their result on the base of higher similarity score to a lower similarity score. Compounds may be filtered by specifying desired range for molecular properties that are commonly used to identify drug-like molecules. The another feature that is Pharmit provided by a filter menu is we can also filter them by their molecular properties of drug-like identities. That will be those include molecular weight, the number of rotatable bonds, log p-value, topological polar surface area, and the number of aromatic groups, and the number of hydrogen bond acceptor, and the number of hydrogen bond donor. We can also filter our result by using these filter. By applying these filter, we can also apply a molecular weight requirement, and their hydrogen number of hydrogen bond acceptor and donor, and the lipophilicity rate. These properties are pre-computed by the OpenBabel. The next is about database selection. When the user is satisfied with the query and constant, a database to search should be selected by pressing the arrow next to the first button on the left sidebar menu. The options include Campbell 20, ChemDiff, Molpot, NCI, Open Chemical Repository, and PubChem, as well as several publicly available user-contributed libraries. When the users are done with their query and their constant shape constant, then the next step is about database selection. Database selection is the user can select their database by pressing the arrow next to the first button on the left sidebar menu, and they can choose their own compound libraries, whatever the user want, and they can also choose a pre-built compound libraries that are already available in the Farmit server. And any public or private libraries the user has personally submit using the create menu accessible from the Pharmit main page. Once a database selected, pressing the search button initiate the search. The user can also use their own submitted the user can also use their own created libraries, submitted libraries by creating a menu accessible option, and then they can start their searching process. In this picture, there is shown that the hit reduction filter menu show a hit reduction and hit screening option. Hit reduction is all about configuration, and hit screening where we can use a molecular weight. We can also choose our molecular weight requirement, rotatable bonds, lipophilicity rate, polar surface area rate, and the aromatic range, and the number of hydrogen bond acceptor, and the number of hydrogen bond donor. It's totally about the depend on the user requirement. What's the user requirement? And the next is about searching a database. Search NCI open. When the user click on the sidebar menu, then the user can choose a pre-built compound libraries, and they can also choose a contributor libraries that are all available in the Pharmit. And when the user choose a database for screening, the next process is about searching. The next is about saving and loading session. The two buttons at the bottom of the left sidebar menu enables users to save and load Pharmit sessions. Saving a session generates a file documenting the receptor, features, visualization state, shape constant, and any other additional features the user specified. The button at the bottom of the left sidebar menu provide a user the ability that they can save their session, Pharmit session, and they can the session will save the representing receptor, their feature, their visualization step, and their constant, and the other feature that the user specified. The file can be loaded to recreate the state of the interface at the time of the file was created. The file can be when the saving session is done, the load session provide the file to load the file that we will and that the user saved previously, and the feature that it select will and the feature that will selected at the time of creating the file, it's also shown when the session is loaded again. In this picture, there is an option shown that the load session and save session. Through save session, the user can save their query, and load session is that all about that the user can upload their save session by in the load session option. The next step is about managing search result. When a database search is initiated, a right sidebar menu opens to display the search result. When we select the database and we start our searching, the right sidebar menu opens and display the result of the Pharmacophore query. The sidebar may be hidden by pressing the right facing arrow at the top left of the sidebar, or it may be closed by pressing the X in the upper right corner. Result may be sorted in increasing or decreasing order based on RMST, mass, or number of rotatable bonds. We can also hide them or show them by pressing a X in the top right sidebar menu, and we can also sort our result on the base of RMST, mass, or number of rotatable bonds in increasing or decreasing order. As this picture shows that when the search is initiated, the results are shown in the right sidebar menu, where we can rank our result on the basis of RMST, mass, and rotatable bonds. Saving and minimizing result. Using the scoring function, a more negative score indicates that the corresponding interaction is more favorable. According to the scoring functions model of protein ligand interaction, thus large positive scores indicate unfavorable interaction and large negative score indicate that more favorable interaction. When the user search on the base of molecular shape, then they can minimize their result and they can rank their results on the base of scoring function. The more negative score indicate that the interaction are good, and the more positive score indicate that there is an unfavorable interaction. Once the filter have been set as a desired, the user should press apply to enforce them. Pressing save after minimizing the result generate a single STF file containing the minimized structure that includes their minimized score. It is often useful to rank the structure in order of increasing score so that the best result can be reviewed first. Once the filter have been done, then you can apply the your desired filters by pressing the save option after the minimizing result, and the minimized result contain a structure on the base of a scoring function. The higher scoring, the more negative scoring function are displayed first, and then further on, and the file is generated in the single STF file containing and in the STF file format. In this picture, the user can minimize a result on the base of maximum score, what's the maximum score, and the maximum RMSE, and then they can apply. When the user can apply, the result are shown in this form. The more negative score indicate that the more favorable interaction, and user can save them, and the save file will be in the form of STF. The next is user submitted databases. User may submit database to be used for search using the create area of the main page. When the user open a Pharmit server, there is a main page that contain a create area where user can create their own libraries by logging in through their email or password. If a user chooses to proceed as a guest, not private database may be submitted, and public databases the user submits have a maximum size of 10,000 confirms. When the user choose a process by proceeding as a guest, the user may not submit a private database, but they can submit a public database that will have a 10,000 confirms. If the user create an account and login in, the user may create one private database with at least 1 lakh confirms, and public database with the user submitted may have at least 10,000 confirms. When the user create their account and they login in, then the user can submit a private database with the 1 lakh confirms, and they can submit a public database by having a 10,000 confirms. This database file should be in smileys or STF format. The database they are submitting, their format should be in the smileys or in the form of STF format. Confirms will be automatically generated from smiley string. The confirms when the user submit a smiley, the confirms will be created by smiley strings, but the structure contained in the STF file will be used directly and should therefore be created using a high quality confirm generator. But the structure contained STF file, the STF file will not be further generate. It can be directly used, and therefore they can use a high quality confirm generator for generating the confirmers when the STF file is uploaded. The next is about how to create a new database for a compounds. You have to mention a short descriptive name of the database and a long descriptive name of the database, and then you can mention your assess who will assess this database. So we are choosing anyone will be assessed and can search. Then you have to upload a file in the form of smileys or in the form of STF. Then you have to submit a database by clicking on submit. The next is why we use Pharmit when the other software are available for visual screening. Screening of large compound database using Pharmacophore molecular shapes. Pharmit provided two ways by which user can perform their visual screening on the base of Pharmacophore generation and on the base of molecular shape. There are multitude of software packages and web services that assist in computer aided designing data, typically batch processing service may service where the user submit a virtual screening job and receive the results hours or day later. Pharmit provide a user ability. They can create their own pharmacophore query and they can search, and the result can be shown within a few minutes. But there are other web server data on the base of batch processing where users submit their pharmacophore their compounds, and they can get their result within a day or within an hour. The user cannot create their own requirement pharmacophore query as like Docplaster, iDrug, iStar, and ELEA3D and MTI Open Screening. These are the other virtual screening options available for screening process. Pharmit provides both pharmacophore and molecular shape search modalities as well as ranking of the result by energy minimization. When the user perform a visual screening by the process of pharmacophore generation or molecular shape constant, there is another additional feature that Pharmit provides is about energy minimization. User can minimize their result by energy minimization step after the results are shown. In addition to providing a variety of pre-built compound libraries, allows user to upload their own compound libraries for screening. Pharmit have their pre-built compound libraries, but they also enable the user that they can upload their own compound library for the screening process. Next is we can go through a practical work. So we can start our practical work. We can access a Pharmit server by this website. The Pharmit main page shows the enter Pharmit search option, and by starting from PDB session number, and the user can submit their own compound libraries by logging in. So we start our process by enter Pharmit search. The enter Pharmit search take to this main page where user can upload their receptor and they can upload their ligand. Load feature will include also pharmacophore feature generated from the external source like MOE. So we can upload our load receptor by load receptor option. The receptor should be in the form of PDB, STF, whatever the format it is. So here we upload our receptor file. As the receptor file is loaded, now we upload our ligand. The ligand should also be in the form of STF, PDB or whatever the format you have. So here we upload our ligand. As the ligand is loaded, the left sidebar menu shows that the pharmacophore features of the protein ligand interactions. The Farmit automatically detects its protein ligand interaction as these interactions are shown. Aromatic ring, hydrogen donor and hydrogen bond acceptor, and hydrophobic regions. The user can create their own pharmacophore query. What's the user requirement? The user can also add shape filter menu where they can include or exclude shape. Include is all about ligand shape and exclude is all about receptor shape, where user can also have a filter menu option where they can hit reduction by reducing their maximum hit per configuration or per molecule or total, where they can also hit screening reduced by their mentioning their molecular weight and their rotatable bonds, number of rotatable bonds, and the lipophilicity rate and polar surface area rate and the number of aromatic rings and number of hydrogen bond donor and acceptor. And this last is about visualization, where user can visualize the ligand in the form of wire, spheres or none, and they can also change their colors, and they can also change the results in the form of sticks, wire, sphere, none, and they can also change their colors, and they can also change the receptor in the form of wire, sphere, cartoons, and they can also change their color. And they can also change their opacity, receptor surface area opacity. And now we can create our own pharmacophore query. So we add some features and remove them. There is another option available for a user. They can adjust their radius and their phi L psi angle. We are adding some features and removing. So we added a 4 features that is about aromatic ring, hydrogen donor, and another hydrogen donor and hydrogen acceptor. Now we select our database. By selecting our database, we can choose our pre-built compound libraries, and we can also choose our contributed libraries. So we are choosing from a contributed libraries. So we are choosing natural product atlas database. As the database is selected, now we can click on it and the searching process is started. As the searching process is started, the results are shown. 6,861 hits are shown. So we can rank our result on the basis of lower or higher IMST by clicking on the arrow. And we can also filter our result on the base of mass and rotatable number of rotatable bonds. As we load our receptor and ligand both files, so we can also minimize our result. The minimization option is only for a molecular shape, visual screening. As the searching process is minimizing process is started, here we can see the scoring function and the minimized RMST. So when the minimization is started, we can filter our result on the base of score. The more negative score indicate that the more higher interaction and the results are good, and then we can save our result in the form of STF. As the results are saved, and we can load our previously saved session, and we can save our session by clicking on a save session option. It will contain all the filter that we applied on the ligand shape. When the save session is done, we can upload a previously a save session by a load session option. As we are working on a Pharmacophore, so we only focus on a Pharmacophore results. We can go back to a Pharmacophore result by pressing on the X shown in the right menu bar. We can also see the ligand that are selected from the database by visual processing through a visual screening process. Now the visual screening is done.